We have 3. And we have 4. Holy crap. The old quad mode. I remember doing this once on a really small data set back on the East Coast, and I had 5 modes. It just, at that point, it gets ridiculous talking about modes at that point. So, and look at Robin's blowing through it. 1 bar stats. Boom. Oh, cool. Good. If you only have your data listed raw, you don't have to go ahead and put L1 in. You can just put 1 bar stats. But that's totally fine. It's not wrong, of course. All right, so here's our summary list. So what do you think? Tell me some stuff about us, friends. Tell me some stuff about us. How many states have we visited? On average, about 17 and a half. Good, 17. On average, about 17 and a half states.
I think you added
Okay. Oh, we're getting different results?
Yeah, it's supposed to be at 16, not
16.
17.
We'll go back and let's look at the data again, Robin. Go ahead, stat, edit. Let's do a little laundry check. 15, 10, 9. Oh, there's an extra 23 in there, maybe.
When I put the 23 in, yeah, probably.
So just press delete.
Where is the delete button?
DEL right above stat, I think.
Yeah, it's right above stat.
Oh, a lot of the stuff's worn off my buttons. I think it's right above stat.
Yeah, no.
There you go.
Okay.
9, 7, 11, 20. I think you're good now. So now go over to cap. Yep. There you go. Rerun it.
Pushing it out.
Go ahead, go for it. Hit enter. 17?
Yep.
Getting at about 17 states. There we go. We'll take it to the nearest state. Okay, so on average we got 17. What else? What other measures do you have?
Standard deviation.
Good. Plus or minus how many?
9.9.
Good. About 10 states. If this data is bell-shaped, that tells us something about it. I'm not that concerned about bell-shaped data today because it's not as important as it was for strictly looking at just these 2 values. We'll look at something else today. What else you got? What else you got? Give me anything else.
Medians.
What's the median?
14 and a half.
Got a median of about 14 and a half states. I'm starting to get a bit of a look at this distribution. I'm getting a bit of a look at it. Seeing 14 and a half, 2.5 south of 17. I got a feeling maybe there's an outlier in there. That 41 might be pulling the average up. Maybe. Just guessing here. We have 4 modes, I heard. We have 4 modes, which is interesting. It's very, very cool. That happens with small data sets. Can we get a histogram? Just to see if my hunch is correct. Get a histogram. So ready for this? Ready, Robin?
I don't know.
I'm going to walk you through it.
Okay.
Second, y equals top left button of the entire thing. Top-est leftist button on the entire machine.
What? Right under the screen.
Top-est leftist? That was pretty cool.
Stat plot? You have to do second. Okay.
There you go. Do me a favor, Robin. Press 2.
Just the number 2?
Just the number 2. Press right arrow. And then press enter. Okay, now press second y equals again. We're going to go to plot 1. Go ahead and press enter on that one. Now make sure it's on, just like that one is. Make sure it's set to histogram, just like that one is down here. That's highlighted over there. Everything's good here except for the frequency. I don't want L2 for a frequency, so yep, L1's good. I want to change frequency to 1. Go ahead and press 1.
That's what it says.
Notice that Robin got a Y, not a 1. Remember, there's a weird bug on the TIs. So you have to do is go back over there, Robin, on top of the Y. Press the alpha button, which I believe is green. Yeah, and now press 1. There we go. There we go.
And then,
Yeah, I was.
Yeah, it's a bug. It's a bug TI has never really fixed because they don't have to. Now just press. What's the cool shortcut for getting a good graph scaled down the proper size?
Zoom 9.
Zoom 9. So the zoom button, which is dead in the middle of the top row.
Okay.
Yep, just says zoom on it, and then the number 9. And there you go. Looks like my prediction was ish correct. We got a little bit of skew. We got a little bit of skew in our data. It's tailing off exponentially. There's that 41 way over there on the outside over there. Now from here you can finagle if you want. You can finagle. Do me a favor, hit the window button, which is the one between y equals and zoom. And remember, friends, if this seems like it's lightning fast going through, remember all this stuff is captured on the videos. And you can get back to this discussion of how to push the buttons. And there's also the screen. There's also a booklet on the enrichment page of the website where all this stuff is outlined. So there's resources. Don't feel like it's too much to comprehend. X-min goes from 7 to 47. Since we're talking about numbers of states, let's make X-min 0. So just type 0 there, Robin, and make X-max 50. Nobody's near 50, so we can just call it 50. Okay, make the X scale, make it 5 if you would. This will be 5 states at a time. Now just press the graph button, which is the furthest right on that top row. There we go. Now you're broken up in 5 state increments. So here's 0 through 5, 5 through 10, 10 through 15, 15 through 20, 20 through 25, 25, 30, 35, 40, 45, 50. No, I jumped one somewhere. But you see what I'm getting at. Still skewed, which we kind of figured it was going to be. So I don't really want to talk about empirical rules because it doesn't fit. It doesn't make sense with this data. Like the whole 95, 68%, 95% doesn't kind of fit in this situation. Beautiful. First thing I want each and every one of you to do, assuming your number is up there. Remember how many states you guys have visited for Monday? Find your state up there. Find your percentile rank. Calculate your percentile rank. Remember what that was? Remember what percentile rank was? It's the percentage of people that you good have been to more states than are above. So you figure out the percentage. Now, overall, there are 16 responses up there. So you have to do a little counting.
Can you please remind us how we do?
How to count?
Just in case.
No, I can't actually. I wish I could remind you how to count. Actually, I did on that first quiz. No, second quiz. Lied to you. Second quiz. I had that big block of numbers. There's 100 numbers. Go in there and count all the ones that are more than whatever number it was. So now your job is to go in there and count all the numbers that are less than you. Not equal to, just less than. Just less than. Number that you exceed. And you're all going to have different numbers. So I want to hear what some of them are. Who's got theirs? Who's got theirs? Mimi, what percentile are you? 0. The 0th percentile. Oh, Mimi. That means you're 7.
Yes.
You're 7. And so is the other 7. 0th percentile. And this is one of those things where certain people come up with other formulas to avoid the 0th percentile. And we'll deal with that on your second take-home part of your exam. Because it's 0th percentile. Jordan?
43.75%.
He's the 43.75th percentile, which means Jordan has been close, a little bit shy of 14.5 states. I'm going to guess, Jordan, that you are the 14.
No.
You're the 11?
No, I'm 15.
You're 15. How can you be 15?
That's median. I did 7 over 16.
Oh, I see what happened, because it's an even number. I was figuring it's an odd number of data. Yes, I was being too literal. Very nice. So he landed right at the middle, which actually, if you think about it, your median being the middle data point, when you do percentile rank, when you go strictly below, you're actually going to be just less than half. Good, good. 43.75th percentile. Come here, some other ones. We got some other ones. Jen, say that again. 87.5th percentile. You're the top, just below the 41, I'm guessing. Yes, there we go. 87.5th percentile. See another one.
It's like 5.
Jane is the 5th percentile. You got 0.05. You got 0.05. What's the matter? You sound so depressed.
I don't know if I'm doing it right.
You're the 9?
I'm the 11.
You're the 11. So, how many numbers up there are less than 11?
I think 4.
Yeah. I got a 9, a 9, a 7, and a 7. So there are 4 less than 11, less than your 11,
So I'm the 4.
and there are 16 total.
So I'm the 4.
Actually, you're the 25th percentile, aren't you?
Oh, okay. Yeah.
Right, think about why.
Yeah.
Let's do Jada's as a concrete example. She looks up at that data list. Let's slide this so you guys can see it. Okay, there's your data list. She's been to 11 states, and so it's somebody else. So somebody else has the exact same percentile as Jada with the 11th state. You look at that block of data. How many data points are less than 11? All the single-digit ones. 7, 7, 9, and 9. It's 4.
Oh, but there's a 10 also.
Oh, there's a 10. So that's 5. I didn't miss a 10. So there's 5 out of 16.
Oh.
5 out of 16. Turn that into a percentage, and that's your percentile rank. 5/16. That's all it is. That's your percentile rank. Cool. That's all percentile rank is. Jordan, go ahead.
I was wrong. It was 50%.
Oh, gotcha. Perfectly percent. Gotcha.
So then what would be the percent if it's like if you have like 4 or 3 numbers after the decimal, do you just take it 2?
Say that again.
Like what would be the percent, like so 0.3125 would be 30.
Oh, gotcha. So just call it the 31st percentile.
Oh, okay.
Yeah, this is where the ishing comes in that Trevor was kind of jokingly referring to earlier. 0.3125. It's funny, I just had a conversation with a student who's taking physics and calculus right now at the same time. And physics is Bruce Emerson. I don't know if you guys have read Bruce in the class. And calculus is Charlie Nassiger, who teaches math up here. And one of the answers in calculus came up as like 3.812121212. And the physics kid in the back goes, that's like 4, right? And Charlie flipped, like, no, it's 3.8121212. Yeah, but that's like 4. We're like the that's like 4 group here. It's like 31%, right? The 0.25, okay, it's 31.25%. 31st percentile, totally fine. And I always tell you what to round to anyway.
Right.
So yeah, we're all about that. There was that one question on the exam where it was saying things like, is it above, below, or at average? I wanted you to not worry about ishing there. Just is it above, below, or at? I try to keep the ones on those in-class ones literal. But as far as reality, it's 31%-ish.
Okay.
31-ish. Is that fair? You guys all buying that? So you guys can all calculate your percentile rank. I want to swing over to here again and kind of revisit this idea. These beautiful things that we just talked about here, we didn't even use in this calculation, except for Chris, or Jordan. Chris. Except for Jordan, who fell right at median. So these guys right here, I like to call these measures of absolute position. And the reason I like to call, do you remember why? I think I may have mentioned this on Monday. What's the word absolute referring to? Do you remember? Say that again,
The positive or negative, but it's still like the distance away from.
Perfect, yes. So you've got an average, or a median, but we tend to focus on the average more. And this guy right here, and this guy right here, they are absolute distances. For example, the standard deviation. It's with reference to a fixed value, an absolute value, and I'm not using absolute value mathematically, I mean an absolute numerical value. And this guy is fixed with respect to him. The median is fixed with respect to putting the entire data set up and finding the geographical middle. The mode is fixed with respect to you're counting the highest frequency. I left the mode off because it's kind of fun, but silly in this case. So I like to call those absolute positions because the only way they exist is because with reference to an absolute fixed value. What you guys just calculated, I like to call relative position. So let me come over, let's put it down here. So percentile rank. Draw a line here. Percentile rank. Okay? This is an example of a measure of relative position. Exactly. Why do you think I call it that? Relative. Relative to what? I mean, the idea of relative is relative to something. So relative to what?
Or titles.
Good. Very nice. Or percentiles or deciles. Very nice, Jordan. Perfectly said. It's you looking at your data point relative to all the other data points. Your value of percentile rank only exists because of its placement within the entire data set. So as it falls, the median, I'll put that line there, but the median can kind of fall into both, because the median is halfway up in size from the bottom to the top. Although I tend to have it kind of fall into this absolute idea. It kind of lives in both worlds. Percentile rank, for sure, exists in the measure of relative because it exists only as referenced by the other data points of the data set and where it falls with respect to those. So that's what your percentile rank is. And just think of percentile as that. Percentage that you go larger than. That's it. Keep that in mind. There are many other formulas, some of which we'll explore in your next take-home exam, but none of them deviate too far from that basic idea. So when your child comes home with a standardized test result and they got in the 99.99th percentile in mathematics, you smile, you pat them on the head, you say, nice job on your math exam. Because that means that they did better than 99.99% of all students that took that exam. When Max goes to the doctor and he's in the 85th percentile for head girth, all that tells me is the kid's got a big head, bigger than 85% of those in his age group. I think I've told you, since that 2-year-old checkup, he's begun to come back down more towards middle. When I say middle, I mean 50th percentile. He's become more normal head girth thicknessly. That's a word now. Forever on YouTube. We also mentioned a couple other quick little ones called quartiles, and I want to spend the rest of our time, it might not take us the entire time today, I don't want to go past this data set, but I want to play with this idea of a quartile as it compares to a percentile. So there are technically 3 quartiles, Q1, Q2, and Q3. Q2 is the median. I mean, nobody calls it Q2, they call it the median. And the median, that's why I say you can kind of live in both worlds. The median is the dividing line between the lowest half and the upper half of the data, smallest half and largest half. This guy Q1 is called the lower quartile. And I think we talked about this guy in class last time a little bit. What do you remember about him?
25%
Say that again, Jay.
bottom 25%.
Absolutely, it's like the median, but it's the median of the lower half. So kind of make that connection, and we're going to do a nice graphical of this in a second with a dot plot and a thing called a box and whisker plot. But it's the dividing line that separates the lowest 25% of the data from the upper 75%. The median separates the lower 50 from the upper 50, and this guy here is called the upper quartile. This is called the upper quartile. He separates the lower from the upper 25. Exactly. So as percentiles, these are all percentiles as well. These are all percentiles. Your median is going to be which percentile?
P,
Say that again. P sub.
P50.
Absolutely, P sub 50. He's the 50th percentile. Your lower quartile is P sub.
25.
Yes, ma'am. And your upper quartile is P sub.
75.
Yes. There is no P sub 100 or P sub 0, although technically we can calculate small data sets that have them. So technically speaking, there are 99 percentiles, although as Jordan pointed out, and as Haley pointed out, you can have 31.25th percentiles or 43.75th percentiles. There's many other percentiles, but as keeping it in the realm of what a percent means per 100, it's splitting a data set up into 100 equal pieces. The problem I see with that, with splitting a data set up into 100 equal pieces, is that it's too fine-toothed to comb. And that's why I like these, because they exist in the world, and I like kind of working with you guys on stuff you'll actually see in the world, as opposed to a bunch of stuff that you never see again when you walk out of here. But these are also prevalent in the world, and also exceptionally useful to us. So here's what I want to do. Let's turn the TI off for a moment. We'll come back to him. We'll come back to him because he's definitely helpful. And what I want to do over here is I want to revisit an old friend. And that old friend is called a dot plot. Can we make a dot plot for our state data right now? That's a stupid question. Of course we can. Let's make a dot plot for our state data right now. So we've been from little number line here. We go from 7 to what the hell? Let's just go from 0 to 50 and break it up accordingly. 25, 5, 10, 15, 20, 35, 40, 45. We'll pretend that's perfectly spaced. And we'll get back to technology, I promise. We won't let this go without technology, because that's kind of dumb. Technology gets us rapid answers every time, but technology without kind of a manual introduction also is kind of bad, because it hides what's going on. So let's go ahead and grab and put our data on our dot plot. We have 2 7s. So that would be here-ish and here-ish. We've got 2 9s, here-ish and here-ish.
110.
A 10.
11.
2 11s, right?
2 11. Sorry.
Here's our skew happening.
114.
A 14 and a 15? Absolutely.
215.
2 15s, one of our 4 modes.
222.
2 22s, a 23. A 25, yes?
Yeah.
I should have done a sort in the damn TI, so it would be much easier, wouldn't it? It's okay, we're halfway done now. More than halfway done. 25, I see a 41, a 34. I'm going to slap those on here. 41, 34. Is that it? Hell yeah. There's our dot plot. Okay. We've got ourselves a dot plot. We could find the average again if you wanted to by using our balance analogy. But you can see why a lion's share of your data is kind of clustered in this area and then it begins to tail off, but you can see the average has to head over this way a little bit. Even though the lion's share of your data is kind of clustered over here, it has to move towards those extreme values to balance properly. So I don't even want to talk about these two today. Can you find the median on the dot plot without having to go to this 14 and a half here? Could you find the median on that dot plot by simple location and counting? If so, tell me how. How could we find the median, even though we just found it using our technology? Go ahead, Quirted. What did I call you, Chris? Yes, exactly. Chop. I'm going to cheat a little bit. It's such a small data set. Since there's only 16, I'm going to go in 8, and it's between the 8th and the 9th, which would also be found by chopping. So let's just do that real quick. Now 1, 2, 3, 4, 5, 6, 7, 8. 8 was 14. 9 is 15. So the median's halfway between those at 14 and a half. Is that fair?
Yep.
You guys buy that logic? There's your median. There's your median right there. Okay. So we know the median for our state data. This is for state data here. I'm going to put it down here. State data. So we know the median's 14 and a half. Yeah, say that again? No, go ahead.
No, it's not.
No, it's. Oh, yeah, it is. Oh. What's the first quartile or the lower quartile?
Would it be the fourth between the fourth and the fifth?
Listen to this. So what we're going to do is, we're going to use the definition we set up on Monday, which was the quartile separates the bottom 25% and the upper 75%. Well, the bottom 25% is the lowest 4 data points. So we go 1, 2, 3, 4. So that's at 9, correct? The next one up is at 10. So our lower quartile should be at 9.5, if you think of it that way. So I'm going to add these to the diagram. I think that might be helpful. Here's your median. Here is your lower quartile. And you see what you're doing is having 16 is actually a very nice number to have because it splits up 4 ways perfectly, 4, 4, 4, and 4. It doesn't always come out that prettily. For example, if you had 17 or if you had 19, they don't split up as nice. 16 splits up beautifully. So you've got 4 data points, down here. 9.5 would be your lower quartile. 9.5 states.
Just because you take between
the 4th and the 5th.
4th and the 5th points.
But even better, more general, Haley, if you don't mind me being more general, it's you take between the lowest 25% and the upper 75% of the data.
Oh.
That way it works for all data sets and not just a small one that has 16 elements in it.
Right.
Is that fair? So I like that better, and the damn light went off again. I thought I had that figured out. Somebody told me if you use the numbered buttons on the side, the light won't fade. Liar! It's okay, we'll just keep walking back and forth. So, Haley, does that make sense?
Yeah.
Great question. Her question was, is it between the 4th and the 5th? For sure, when the data set has 16 data points. But if it doesn't have 16 data points, just find the separator between 25% and 75%. And when I say just find the separator, let technology do it for us, which it will do relatively soon. But I like this visual at first. I like this visual at first because otherwise the magic of technology hides what's actually going on. Where's Q3? Where's your upper quartile?
24.
We found it in 24? Let's figure out. We can do the same thing we just did with the lower quartile, but reverse it and go from the top. So let's come in 4. We got 1, 2, 3, 4. What was 4? That looks like a 23. That's a 23. So I'm going to put a dividing line between these 4 here and these 4 right here. So it's actually a little bit less than 24, isn't it? Isn't it going to be 22 and a half? Everybody following that logic? This little data point right here is 23. These guys are 22s. So directly between them is 22 and a half.
Wait, where did you start counting?
I started from the top this time, Haley. I said, okay, come down 4.
Oh.
Because 4 out of 16 is 25%. Fair enough? So I go 1, 2, 3, 4. Okay, divide between that one and the next one down, which is 22, which means my lower quartile is going to be 22 and a half states. Which means, and now recapping this in English, because this is all stat ease right now. Yes,
The median is 14.5 states. The upper quartile 22.5. Lower quartile 9.5. Yes, for us day.
what does that mean again? What does it mean when you say the lower quartile is 9.5 states?
25% is below and 75% is above.
Yes, 25% of students in the class have been to fewer than 9.5 states. Conversely, 75% have been to more. 75% of students have been to fewer than 22.5 states. 25% have been to more. half of students have been to fewer than 14.5 states, and half have been to more. All you're doing is you're placing these sliding dividers in your data set, which adds up to 100%, and you're giving it a reference point to above or below. That's all these things do. That's all they do. I mean, that's honestly all they do. I mean, they don't do anything more. Other scales are used. Sometimes deciles or deciles are used. Instead of having 4 chunks, there are 10. So the 10th percentile, the 20th, the 30th, the 40th. Sometimes quintiles are used. There are 5 of those. 20th percentile, 40th, 60th, 80th. What other ones are used? I think those are the most common. The government likes quintiles for some reason. Deciles are sometimes used. Quartiles are just, they're the nicest to kind of deal with because you get some measure of interesting, but not the annoyingly tiny measure of interesting that you get with percentiles. Fine-toothed comb, much broader toothed comb, but at the same time you still get an idea of spread. Now, which of the 4 quarters of data are most spread out?